Hello everyone, this is the first lesson recording for IM1, November 10th, 2020. We started off by doing the quiz number 5 on combining like terms and multiplying polynomials. So if you are absent for this quiz, please contact me as soon as you can so that you can make up the quiz. Then we went on to doing a Desmos exercise. This is a quick one relating two different quantities. This is looking at the graph to see the different data different axes represent. So the x-axis and the y-axis. So let's do that quickly. This is the first card. The first card asks you to drag the point to change the robot. What do you notice? So if I just move this around, look what happens to the robot. The robot gets taller and shorter. And if I move it from side to side, look what happens to his eyes. The eyes are farther apart and then closer together. Okay, so why is that? That's because the x-axis represents the eye distance. So if I make it farther away, that means the eye distance gets farther apart. So distance between the eyes are bigger, but as the eye distance gets smaller, the eyes are closer together. And the y-axis is the height. Okay, height is, so it tells me if I move it up and down, it changes the height of the robot. Okay, so the x-axis and the y-axis tells us a lot of things about this robot. So that means, let's go on to this one. Okay, so describe something you know about robot based on this graph. So this dot represents this robot's data. Okay, so looking at this, the first number is 2, the second number in parentheses is 25. Remember, the first number is always the x value, the second number is the y value. The x value meaning you look at the x-axis and look at what it represents. The eye distance is 2. And the y value is, what's on the y-axis? The height is 25. So I can write this robot's eye distance is 2 inches and height is 25 inches. Okay, and that could be my answer. All right, let's go on to the next one. Move the points on the graph to represent each robot. So there are 4 robots and they have different heights and different eye distances. I noticed that the orange robot and the green robots, they are same in height. They are the tall ones, and the purple and the blue ones are the short ones. But between the tall ones, they have the same height, but the orange one, the eyes are farther apart. The green one, the eyes are closer together. So I would expect orange and green to represent one of these two. But between these, the orange one had the eyes farther apart. That means the eyes, it will be bigger. The distance, eye distance will be bigger. So my guess is orange one, orange will be represented by this, and the green will be represented by this, because they are both tall, but green is the one with the eye distance smaller, and orange is the one with the eye distance that is bigger. Okay, what about between the two short robots? The one with the eye distance that are closer together, that means smaller eye distance, will be the purple. So I'm going to bring him down here, and the blue is going to be right here. Okay, and we can try it. And it matches up. Cool. And the blue one, good. And the green, so I had this correct. You can move on to the next card. Okay, now the table below shows the height and eye distance of 5 different robots. Drag the pink points to represent the pink robot. Okay, so they have teal, brown, yellow, silver. Teal, brown, yellow, silver. It's represented by these points, and they've actually graphed it for us. And the points that represented are these data points, right? Now we're told the pink one has the eye distance of 8 and the height of 20. Okay, so height of 20, looking at this, All right, so the one that has the height of 20 is the brown one. That means pink is going to be sort of same in line somewhere along here. Okay, it's the same height as the brown. I know that. Okay, and then what is the eye distance? Eye distance is 8. Eye distance is 8, which is the one with eye distance of 8. It's silver one. Okay, good. I actually happen to have put it in the right one then. Okay, so it had this has the same height as the brown, which is 20, and the pink has the same eye distance as the silver. Good, so this will be the correct one. Now this time the graph shows the height and eye distance of 8 blue robots. Move the red point to make the statement true. The red robot is taller than all the blue robots. So we have all these robots. So for example, this robot has eye distance of 2 and height of 38. Okay, but we want the red to be taller than any of them. So this one will represent the tallest of the blue robot, but we want the red to be taller than that. Okay, so maybe if I put it somewhere here, that would work. Okay, but its eye distance is 5 inches. So currently the eye distance is like 1.5 inches. We don't want 1.5, we want it to be 5. So I am going to bring that over here. Okay, so in this point, at this point, the eye distance is 5 and the height is 45 inches, and 45 inches is taller than any of the blue. Okay, so then let's move on. Finally, here is the scatter plot showing the height of some robots. Okay, so these each represents different robots. Okay, each of the dots represent different robots, and each of these dots represent the eye distance and the height. So each represent robot giving you 2 different data points. So one is describing its eye distance, the other data point is giving you its height. So circle the point representing the robot with the greatest eye distance. Okay, greatest eye distance, that's the x-axis. Which is the robot with the greatest eye distance? Which is the one with the biggest number here? It's 13 here. Okay, so that's the one. So I am going to circle that one. It's this point right here. Fill in the table with the values representing the robot with the greatest eye distance. So the eye distance, what is the eye distance here? It's this point. This will be 8, 9, 10, 11, 12, 13. This will be 13 here. So the eye distance will be 13. And the height, what is the height? To find the height, I need to go to the y-axis, and that will be 40 inches. Okay, so I know that the robot with the greatest eye distance was the one with 13 inches, and the height was 40 inches for that. Okay, so that was the first Desmos exercise. Now you're going to go to the second Desmos exercise, and this time, instead of robot's eye distance and the height, this time we're going to compare students' ACT versus their GPA or their grade. Okay, so this is the Desmos exercise that you're going to be working on, just the first 4 cards. All right, so this is the first card, okay? Now, we're given this table. We don't know what the different numbers represent. What do you know about GPA? Well, GPA is just the average of your grades in your high school years, right? So the A's would get you 4, B's will get you 3.5, C's will get you 3. Oh no, am I getting it confused? Okay, no, B will get you 3, C will get you 2, and D would get you 1, and F you do not get any credit for it. Okay, so for each of the subjects you get those scores, and you add them all up depending on how many classes that you took, and then divide that by however many classes you took, and that's your GPA. Okay, what is ACT? ACT is like SAT. ACT is like SAT in that it's an exam that you take to get into university, and universities look at that score to see, okay, is this a strong student? Is this a student that we want to take? Is this student going to be successful at our university, and so on and so forth? So those are the things. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm not really sure what that represents, but we do have a whole lot of numbers for GPA and a whole lot of numbers for ACT. So it's up to you to figure out what you notice and what you wonder. Okay, and then this time we are given a little bit more information here. The data we have is the GPA and ACT scores of 100 students. We've only displayed the first 10 students here because we don't have enough space. But so we have a whole lot more than just these 10 students data. Okay, so we have, this is the first 10 students. So student 11, 12, 13, 14, it will continue. So this tells me student 1 had the GPA of 1.990. Okay, so that means on average, he got C, close to 2, which is on average he got C, maybe some couple of D's. That's what it means. ACT, he scored 20, and it's out of 36 is my belief. Okay, so that means he did 20 out of 36. For the second student, his GPA was much higher, 3.359. That means he's getting like A's and B's in his classes. And ACT, he scored 28 out of 36. Okay, and so on and so forth. So different students are represented by different data points. Just like the robots in the previous Desmos exercises, it had different information. It had the eye distance and the height. But this time we're talking about students having their GPA and their ACT. Okay, so Eduardo used all 100 data points to calculate the average of GPA to be 2.260 and the average ACT score to be 22.6. Explain how he calculated the average. How do you calculate the average of anything? You just add them all up and then divide by however many data points that you use. So if there was, so I would add all the GPA of all the students, all 100 students, and I know that that represents 100 students score. That means I am going to divide the total by 100, and that gave me 2.260. And for ACT, I'll do likewise. I would add all the ACT scores of each of the students, and I know there was 100 students, so I would divide that by 100, and that ACT average was 22.6. So what does the average score tell us? Well, it tells us on average, in the middle of all the GPA. So in this group of students, the middle score will be about 2.260 for GPA, and middle score for ACT will be 22.6. Okay, so then let's look at this one. What did Viola do? She did something different. Viola generated a graph using the same 100 data set. Okay, so just like the robots, she plotted what we call scatter plot. Okay, and the robots were scatter plots, but there were only handful of robots, but this time we have 100 data points. So believe it or not, each of those blue dots represent a student's score, their GPA, and their ACT score, and there are 100 of the blue dots represented in this graph. Okay, so in here it says find the dot for student with GPA of 2.590 and ACT score of 28. 2.590, 2.590 of the GPA. 2.5 is right here. 2.590 will be somewhere around here, so it will be a little bit higher, somewhere along here. And the ACT of 28 would make me think this is this student here. Okay, so I'm going to color that red because when I go across, it looks like approximately 28. When I go down, it looks like approximately 25.9. Okay, find the dot for a student with GPA of 3.0 and ACT score of 23 and circle that green, that student green. Okay, so I'm looking for a student who has the ACT of 23. 23 will be somewhere here. Okay, okay, and GPA of 3.0